need to determine the average tension in a cable. So in that case, we need to only look at A. We can draw the free body diagram for A. Then there will be three forces in this free body diagram. We have WA, NA, and T. T is a tension force in the cable. And we still use the same coordinate system. I pointing to the left, J pointing to upward. And I direction, it's the direction we're interested in to solve tension T. So we can take the sum of the forces, take the integral, and dt equals mva v2 minus v1. Since there's only one force on I direction, so the sum of forces equals just t, right? And then we can write this as integral t dt equals ma va2 minus va1. And this va1, we already solved this from part A. Because we care about the average tension force. So this integral can be written as the average tension force times delta t, which is the period of time equals ma times va2 minus va1. And we can put delta t to the other side of the equation. And we end up with expression for t average, which is ma over delta t times va2 minus va1 on I direction, excuse me. And you can substitute va2 from part A into this expression, and you can, after rearrange everything, you will find your t average equals negative a times mb times vb slash a over delta t times ma plus mb on I direction.